Leslie, and I wanted to give you an overview of Unit 3 for our CSA course. Now, I'm in the SEED CSA course, but it's going to be the same for non-SEED teachers except for the end-of-unit survey. So Unit 3 is talking about strings and iteration. So two major topics, of course, in the CSA course. And we've paired those topics together for the unit project. So the unit project, if you watch the video, introduces the problem of language. So the cast of characters has arrived in South America and they don't understand the language. And so they're going to write a language interpreter program that translates from the native language to English. And so there's several work days here. You've got the launch and then another work day and then some more about iteration, another work day, more about algorithms, and then 2 work days combined there at the end. And so these first couple of work days are a lot of them are unplugged or working with algorithms. So this project is very scaffolded. Students work on a little bit at a time depending on what they just learned from previous assignments. And so it really comes together these last days as far as writing the code for the project. These days, they're just kind of practicing and making some small algorithms that they will pull into the project. So if we look at the launch, we suggest using pair programming. So make sure you turn that on and set your groups up before students get into the activity. So you're going to do the usual, do the launch, read through the assignment and the rubric, have students work on their KWL chart and group contract. These are found under project files, so you can just print those off as you open them. In Codio, you can just then print them off. And then they're going to do some work on thinking computationally about language. So this just gets their brain working and thinking, and they work with Pig Latin. That we have provided a sample solution for you. We have hidden and encrypted the solution files so students can't find them if they have some knowledge of the terminal. So for you to see, this just provides a complete solution file for the language interpreter project, and it's just a sample. Students are going to do things differently, but it's just something for you to review. So first you'll just click this button to decrypt the files, and then you'll click this link to open the files, and here's the code. So there's some comments in here that you can uncomment if you want to test just one word. This is the code that gets the sample. So we are reading from this lexicon. We're creating a lexicon object with this lexicon class. These are the sample sentences that students are going to translate to English. So there's 16 different sentences, so you'll assign a different sentence to each student or each group, so no one is doing the same. And you do that right here under speak.getSample. So 0 is going to be this sentence, and index value 1 is going to be this sentence. So just assign a different index value for getSample to your student groups. So just, work through this code. We're using a loop here. We're using index of. We're checking for INGY. So these are some of the algorithms that students will work on during the work days, the project work days. And then they're going to look for ENT, and then they're going to build their translated sentence, and then they've got to get the rest of the sentence so that they can go do that again, check index of again for each word. So they're basically checking each word by looking at that space. And then they've got to get the last word. So, and then there's some things for punctuation in here. So you may not want to, count for punctuation, and that's fine. That'll be up to you. And you might need to help them out with, make sure that you translate the last word, because that's not going to be included in this while loop. So just, give students some prompts as needed as they work through this code. So as you go through each of the student pages, you've got your video, and then the next page is the assignment. So what they're going to do. So they're going to write a language interpreter program using iteration and methods from the string class. They'll be given starter code, and then it tells them exactly what they have to use. So a specific method to get a speech sample that we've provided, use a loop, use string class methods, print the original speech sample translated to English. So they take a sample from the native language and they have to translate it to English. And then they've got their rubric, of course. So make sure that you go over that. And then this is just getting them to think about language. And so they do a little Pig Latin. They start decoding and thinking, well, how can you translate that? How would you translate that? And so if the pair programming feature is turned on, then only one student is going to answer this assessment, and then it will be graded for both. So I'm in teacher view right now. If you go to settings, I'm in teacher view. So this shows the purple boxes. So this is the correct answer. If you want to view how students can see it, you just turn that off, and then you won't see the purple boxes. So always have that teacher view on when you're reviewing your lessons before you teach them, so that you can see what the rationale, the correct answers are. So the object here is just to rewrite the word without AY at the end. So students will go through that. So that means that AY was added to the end. So you're kind of thinking forwards and backwards there. And then you talk about the rules. What are the rules? Well, there's some rules about consonants and vowels. So talk about that. And then get students to write an algorithm in pseudocode of how they would translate using these rules. So you see you've got your selection statements, which they learned about in Unit 2. So they can use English here. We're not asking them to write it in Java. This is pseudocode. So just pseudocode's fine, and then they're done with that one, and you'll come back and check those. The next couple of lessons then are going to talk about strings. The next lesson talks about strings. So when you look at this strings activity here, you can let the students read through, or you can kind of read through it with them, and then they'll do some research on palindrome. So this is kind of a group activity that they can do, assign each topic, one of these topics to each group, and let them just do some Google research and then report back to the class. So, once they've reported back, then students should understand what a palindrome is, what programs already exist that do that, some things about the string, a couple of string methods, char-at and substring. So each student is going to report back. So at the end, all students will have answers to all those questions. So letting them do some inquiry work. We did introduce strings in Unit 2. So that was the first exposure, and now we're going to do the deep dive into strings in Unit 3. So it just go through the string facts, some sample code, what an empty string looks like, what some escape sequences are, the popular methods of length, substring, and index of. So make sure to review those with your students. Make sure that they understand what the parameters do here. Whether they're inclusive or exclusive, and then index of. And then we talk about equals and compare to. So make sure that you review those. And then there's some assessment. So this is checks for understanding. Did they understand what you just went through or what they just read? So they'll answer these assessment questions using length, substring, index of, and compare to. And of course, you've got the, if you answer here, as the teacher, it checks, the right answer. Then this is the group work assignment. So if you wanted to set up pair programming, or they're just going to put one assessment answer in here, so you don't actually have to set up the setting in Codio. You can just assign groups in class, let them do some research, and then each student can individually answer this. But then you want them to share out, each group, what they learned. And then, of course, this is how we align back to the classroom, AP Classroom. So that's the first introduction to string, and then they're going to have an assignment, the palindrome assignment. This is a 2-class period assignment, or you can assign one portion and the rest can be done asynchronously or for homework. This assignment does use iteration, which hasn't been covered, but the starter code provides the loops for those students. The alternative is you might do this after you do lesson 3.4, iteration for loops. So that's up to you. We suggest this can be a pair programming assignment. Students would work together because they're going to be using some of these string programs. Review kind of what you talked about, what they learned when they researched palindromes. And then they've got 3 palindrome methods that they're going to write. And then the second class period, they're going to test. So I've given lots of test examples and whether they are or are not a palindrome. After this unit, after this assignment, there is a personal project check that students can complete under Unit 2 in AP Classroom Part B. You can assignment, or if you assigned it in Unit 2, you can reassign it. So we do give you that information where we think that is a good place for you to assign those personal project progress checks. All right, so then you just have the coding page. So you've got your IED here, your terminal, the instructions again. So they're writing 3 methods here. If you look at your starter code, they've got to write is palindrome 2, and is palindrome 3. And so we do have the loops in there for them. We've given them a pretty good amount of starter code. The return true, that's if it is a palindrome, they'll return true. So they'll have to add their code for false, return false. And this one actually returns the actual string. So it's a void method. So here are the instructions, and then this is an auto-graded program. Here are sample solutions for you as the teachers to help guide students, but it is auto-graded, so students can check their code as many times as they want to until it passes the auto-grader. The next assignment, we're going back to the language interpreter project. So now they've worked with some strings. So they're going to do a little more exploration. We're not to the programming part yet. We're still scaffolding here. So they review these common string methods, and then using their pair programming, same groups that they had before, just follow these instructions, and they're going to run this program for each one of these words and then fill in what the new language is. So this is in English, so what's the new language do? So remember for the project, they have to go the opposite way. They have to take a new language or native language and translate it back to English. So here they're seeing how did it go from English to the new language. Okay, so they're just running the program. They change this word "the," so they run it, and it's going to be the ENT. So they're going to type that in, and then they're going to change the word to "of," and then they're going to run it again, and they're going to see what it does to "of." OENTFINGY. So then they should start thinking about patterns. Well, it looks like it's putting ENT in every word, maybe after the first vowel, but they need to do all of them to kind of see what the pattern is. So then they are going to write some of the patterns down. Remember, this is your rationale. So kind of guide students to that. And then what would happen if these words were translated? Or would they be? Or would they not change at all? So now you're going to convert these patterns to pseudocode. So that's what you did with Pig Latin. You had your rules and you wrote an algorithm. So now you've got your kind of your patterns up here or your rules, and you're going to translate that to pseudocode. And then we've given you some options there for the patterns. And then which string methods. So it's kind of a review of your string methods to get thinking about, well, how am I going to code this in Java? So they're going to answer those, okay? Then we're going to get into iteration. So the next several lessons are on iteration. First we talk about for loops, then we talk about while loops. For loops and then an assignment. While loops, then we do some tracing, show students how to trace. Nested iteration, and then we do an assignment. Let's see, where are we here? Iteration, for loops. So for this lesson, we just describe the for loop syntax. So go through this together, allow students to read it. They have to understand each component of a for loop. They need to understand the terminology, how brackets play into this. Here's a good life cycle. This explains the life cycle of a loop. And then they get to do a Parsons problem where they put code in order. These are invaluable for students, for them to understand and learn. We talk about off by one errors. And then we have them write code. And we give you the sample code here, and now they change it a little bit. And so they're just working with the code here, experimenting. If I do this, what happens? If I do this, what happens? And then we've got some code where they have to determine, is there an error or not? And then we give you the rationale for that. So they're going to have to think hard, look hard. Do they notice that there's a semicolon there? So they'll go through that. Just little checks for understanding, reading code, being able to read code. And then they've got a program assignment to write the code that counts to 21, and then it's auto-graded. Here's the solution, very simple. And then here's a challenge for those students that are ready for a challenge. Can they add a math.random? And then that's the end of that. So there's your for loop assignment, several introduction to for loops with some coding assignments so they can try things out, see what happens if I do this. And now we have an assignment. Now this assignment, we've given them some algorithm help over here. This is a PowerPoint in a PDF form that you can use to help them. So maybe go over what the assignment is first. There's a lot of standard algorithms in programming, and this is one of them that's going to go through and print the original word in reverse order. So test becomes TSET. So it's going to take the original word and just print it in reverse order. It's auto-graded. Here's a sample solution. We've already talked about scanners, so they should be able to remember how to use a scanner, or if you can help them out, that's fine. Come back here, though, and go through the teacher lesson plan if you want to use that PowerPoint, because it gives you specific notes for specific pages right here. So this is what slide 3 does, slide 4. You know, you want to do it kind of you don't want to show it all at once. Like, you want to give them some information and then let them have time to develop this algorithm, and then maybe you can help them. And then here it is in English, here it is in pseudocode, talking about iteration. So this is some help that you can provide students. We actually do give this, though, on the student page as well. Down here at the bottom, I believe they can click for that algorithm help. And so this is a very scaffolded assignment as well. It's challenging, so we don't want them to get frustrated, so we just kind of help them out. And then the next page is a frequency of occurrence. Very, very common algorithm. How many times does this character appear in a string? And we give them the algorithm, and so then they need to write the code, and it's auto-graded, but we do give them the algorithm, and then here's your code. So, you know, at any time, with you having the solution, at any time your students are struggling or a student is struggling, certainly help them out. We don't want them floundering or getting frustrated. So, you know, you can guide them, prompt them maybe for the next part that they're getting stuck on. After that assignment, we're going to go to while loops. So just a different kind of loop. We compare and contrast. We do some Parsons problems here. We talk about special cases, and then they have a code challenge here, a digit average. So, you know, the text describes the topic, gives examples, and then students, we got check for understanding here, Parsons problems, which are great. Discussion points for you. So this is a point where you would kind of, when students get done with this, you're going to stop and ask these prompts and then generate a discussion in class. So students can have, well, what are these used for? Why would I use a while loop? Can I always use a for loop? Can I always use a while loop? Students kind of end up with a preference of what they like. And so just talk about, most of it does come down to preference, but talk about cases when you would typically use one or the other. So discussion points are often embedded in the code. This is some special cases, infinite loops, a loop that never executes. So that's another kind of loop, and when that would happen. And then a coding assignment here to add up all the digits in a number. So this is a great, very common algorithm to take a number and actually kind of chop off each number and do something with it. And so it gives you the algorithm. This is your teacher guidance. So again, you might need to help students with this, but this is a very common algorithm that they could see on the AP exam, where you take the number and you mod it by 10, and then you get that number and then you divide it by 10 to chop it off. So that's a very common algorithm. So help your students as needed. And then the next is a good lesson on tracing code. We want them to do this on paper. Hand trace this code, so have them write it out on paper, the code they just wrote for digit average. Give them a new number other than this and have them trace it. Here's the example of a trace where they set up a column for each variable that's in the code, and then as they go through each iteration, how does the value change? And then whatever the last is, it's printing out answer. Answer is sum divided by count. So when you're at the end here, sum divided by count. That's the answer. and have them turn that in. This is on paper. So there was just no easy way for them to create a chart really in Codio. So this is an unplugged activity. Any kind of tracing can be unplugged. But it does show them the steps and kind of how we get there and what we do here. Right here's the steps for tracing code, and then we go through an example and then have them do that. So that's a great activity to do. Then we get into nested loops, the syntax for that, and how that what error things you have to watch for, nested iteration, what it is, just iteration statements that are in other iteration statements. So especially like when you're dealing with even two-dimensional arrays, which we'll get into later, you use nested loops. And again, error or no error. And these can be tricky, so students really need to watch, read the code, and then you need to go over the answers with them. Give them a chance to answer the question and then go through. And then how to trace nested loops. And then this is a great one because it's kind of tracing. I guess we can do it in Codio, not just on paper, but this is letting them trace what's happening at each step. So that's a great exercise for them to do. And so is that all on there? Talk about? Yep, that was it. Okay. Now we're back to the language interpreter project. So we've talked about strings and we've talked about iteration, and now it's kind of we're getting there to where we're going to code, but we're still kind of working on the algorithm. So we're translating from the new language to English, and remember their ultimate goal. Yeah, that's their ultimate goal. So this work day is just going to have them read through so this is the new language and this is what the English was. And we did the reverse in project workday 2. Remember, we had the English and we ran the code to figure the new language. So now they're going to write some algorithms. So write the how are you going to find INGY in a string? How are you going to do that? Well, if it ends in, so take the last 4 letters of a word, and if it equals that, remove it. Or use index of. Either one will work there. And then, so write the code, and how are you going to remove it? Well, you're just going to take the word minus those letters. And we're saying that they start at the end. So we go from 0 to the index where we found that. Or since it has a length of 4. So I show you a couple of different options there. Students think differently. Not everyone's going to come up with the same algorithm. And then, so we're kind of doing one step at a time. We got rid of the INGY, and now this is what's left. So now we're still trying to get to of. So now what are we seeing? Well, we're seeing ENT in there a lot. So we probably need to remove that. So it should be similar to what we just did because we removed INGY. But it looks like it's not at the end. So that may change things a little bit. And then don't forget to account for words like lent that had ENT, but it didn't get added to it. Again, answers will vary, and int can be anywhere in the word, so you want to use index of. And then we're checking to make sure the length of the word's greater than 4 to begin with, so that won't get words like lent. So that's the next work day. So we're still not coding. We're still scaffolding. Piece by piece, we're getting to the coding part. And then the last couple of lessons are string algorithms. These are just very common. We already did the reverse word, very common algorithm. We already did frequency of occurrence, very strong common algorithm, counting the number of times a certain characters appear. And then we've got some additional ones here. So again, our methods here We already did that reverse word coding. We already did frequency. So some other things: remove all occurrences of a specific string. Scramble a string. That's a very popular free response question. Find a string within another one. Find all occurrences of a string within another one. Replacing all occurrences. And then see if your students can think of the algorithms for those. Just talk about that for a minute. How are we going to accomplish these things? So talk about that with your students. And then using the remove a string program, here's your starter code. You want to remove all occurrences of a specific letter, number, or symbol in a string. So if the word is bananas, we want to remove all the A's. So that's one of these very common algorithms, the first one. So we kind of give them the algorithm, and then the students should code it and run it. And then we give you a little hint here. If it's not equal to, so yeah, this one is kind of different. We actually build a new string using only the letters that we want. So that's one solution for that. Let's see. So we're doing some common algorithms here. Here's some more quick little programs that they can do. Repeat end. Here's a program here. The starter code's already here. This is going to be a little different. It's using a method, a return method. So just make sure you go over the instructions for them. It does have an auto grader here. Here's your solution. And then is that all for that one? Yeah. And then the next one are just some more common algorithms using index of, because remember, we've got to use that in our language interpreter project. So I think we review the index of method, and then they have to write a method that uses index of, and this is some of the output it's supposed to do. Tells you where to write your code right here. So we're building a new string in a method and returning it back to here. And they're going to do some testing, so they can change some of these values here. Yeah, it says here, change the values to test it, make sure it works. And then that's auto-graded, and then you have a solution here. So programs are starting to get more complex, but students are ready for that. That's okay. Combining selection, iteration, string methods. Here's another little program, quick program that they can do. Same kind of thing, and it's auto-graded. So they're getting lots of coding experience in Unit 3. Lots of quick little coding lessons that they do. So they're not just reading text. I mean, they read text to learn about a new topic, and then they practice it. Lots of coding. Now we're to the project. Now this is 2 days here together. So 2 days in a row, they'll kind of finish their project. And just reminds them what they're supposed to do. So now they're going to put things together that they created in the last day and put so that they end up translating one word, get that working, and then they add the iteration to translate an entire sentence. So we bring in some code. I didn't have anything in there, so nothing's in there. But remember when they had that remove ing and remove ent, well, it's going to be in here for students that completed that. So they're going to be able to copy and paste that into their language interpreter code. Okay, kind of down here. And these comments really help what the next step is for students to do. So they should read those comments. So they should read those comments because that really guides them in their algorithm. They are going to get what they did last time. They're going to be able to, that's going to show up here, so they can just copy and paste it into their program for both the remove ent and the remove ing. Make sure they're in the right order. Then you're going to test it to see if it works. So test it for all these words. Now they're going to translate the entire sentence. So what do they need? Iteration to go through every word. And they've got some, since this starter code has everything in it, they've got to uncomment some of these lines, so make sure they follow those instructions. You as a teacher, tell them which sample to get. There's 16 different samples, so from 0 to 15 for the index value, so that each group gets a different sample. Don't have every student's program translate the same sample. Just, give them a different, your index number, your group 1, index number 1, your group 2, index number 2. Here's a little help with algorithm help. So again, we're scaffolding, we're helping them out here, and then there's a challenge if you've got students that got it and they need something additional. Okay, so that's the project, and that, I believe, is the end of, is that it? Oh, well, they've got some additional, I think, yeah, they're written responses that they need to do for the project. Do a rubric check. Let's see what else. And I think that's all. Yeah. So don't let them forget that last page where they complete these written responses and do a rubric check. And then that's the end. Then you've got your unit review. Unit reviews are always going to direct you to AP Classroom. So it's going to tell you which personal progress checks students should have completed. And remember, I showed you that teacher lesson plans show you when to do those. Here we go. These are the ones that they should have done. If you want to add some additional, here's the vocabulary solutions. If you want to add some additional things from create your own quizzes from AP Classroom, then these are the topic questions that have been assigned. These are the topics that have been discussed, so you could make up your own quizzes according to these topics. And then they've got to do their vocabulary, and then I think that's all. Yeah. So that's unit. This Java IDE, this is just an additional assignment that only has Java IDE. So anytime you want to make your own assignment, just duplicate this from the edit assignments, because all it is blank starter code and a compile and run button. So you can edit this and make your own assignment for students, or I often go in here when I just need to test code myself. It's just, a blank slate, and you just hit compile and run. So that's just an extra thing that we have in every unit. All right, so I hope that helps you understand Unit 3 better, and please reach out if you have any questions, and we'll be doing this for the other units. As we, in a couple weeks, I'll send out a Unit 4. Thank you.